It is 12:01 a.m. on Black Friday. Your marketing campaign was a massive success. 100,000 users just clicked your link at the exact same second. You watch the analytics dashboard. Traffic spikes. CPU hits 100%. And then, silence. Your database locks up. Your load balancer chokes. Your site throws a 503 service unavailable error. You aren't making sales. You are burning reputation. This is the nightmare scenario for every engineering team. But for Amazon, this traffic spike is just another Tuesday. Most websites fail because they rely on reactive scaling. They wait for traffic to hit the server, wait for the CPU to get hot, and then try to spin up new servers. That process takes minutes. In a flash sale, minutes are an eternity. Amazon uses predictive scaling. They don't just react to the load, they anticipate it. Their algorithms analyze historical data from last year's Black Friday and Cyber Monday to pre-warm their infrastructure. They spin up thousands of servers before the sale even starts. But throwing hardware at the problem is only the first step. Rule number 1 of high availability architecture: never let the user hit your origin server if you don't have to. This is the shield. When you load an Amazon product page, you aren't actually talking to their main database. You are talking to CloudFront, a content delivery network with edge locations all over the world. 90% of the data, product images, descriptions, HTML, and CSS, is static. It's cached at the edge, miles away from the core servers. This means that even if 1 billion people visit the site, only a tiny fraction of that traffic actually pierces the shield to reach the backend. For the traffic that does get through, Amazon relies on massive horizontal scaling. In the old days, if a server got overloaded, you would buy a bigger, more expensive server. That is vertical scaling. It's expensive, and it has a limit. Amazon does the opposite. They use auto-scaling groups. As traffic rises, their system automatically launches hundreds of small, disposable EC2 instances. A load balancer sits in front, acting like a traffic cop, distributing requests evenly across this growing fleet. When traffic dies down, the robots terminate the extra servers automatically to save money. But here is the bottleneck that kills 99% of startups: the database. You can have 1,000 web servers, but if they all try to write to one database at the same time, your site will die. Amazon solves this with read replicas. They know that for every one person buying an item, there are 50 people just browsing. So, they split the database. A single master database handles the critical stuff, like processing payments and updating inventory. Meanwhile, 5, 10, or even 20 read replicas handle the browsing traffic. This ensures that window shoppers never slow down the paying customers. What happens when everyone clicks Buy Now at once? If you try to process 1 million credit cards simultaneously, your payment gateway will crash. This is where decoupling comes in. Amazon uses SQS, Simple Queue Service. When you click Buy, your order isn't processed instantly. It's placed into a durable queue. Think of it like a digital conveyor belt. A separate fleet of worker servers pulls orders off the belt one by one, at a pace the database can handle. This flattens the curve, ensuring that even if the back end is slow, no order is ever lost. Finally, this is their secret weapon. It's called graceful degradation. Generating personalized recommendations, like customers who bought this also bought that, is extremely expensive for the CPU. If the system detects that load is getting dangerously high, it doesn't crash. It simply turns off the heavy features. The reviews might disappear. The recommendation carousel might vanish. But the Buy Now button, that stays online no matter what. They sacrifice the bells and whistles to protect the core transaction. So, to survive the spike, you need to think like Amazon. Cache aggressively at the edge. Scale horizontally, not vertically. Isolate your reads from your writes. Decouple your checkout with queues. And know exactly which features to kill when the ship starts sinking. You might not have Jeff Bezos's budget, but you can definitely use his architecture. Thanks for watching, and happy scaling.